if I take a look at this last one, I want to use Pascal's triangle in order to do the multiplication that I have here. And this is my binomial expansion. So the first thing I need is Pascal's triangle, which remember starts with a 1 at the top. When I add nothing to the 1, which are the values beside it, I get a 1 here and a 1 here. Remember, I'm just doing 1 plus nothing is a 1, 1 plus 1 is a 2. I'm just adding the terms next to it to come up with this pattern that's known as Pascal's triangle. So I'm just going to write that out to a couple values here. And that's where I'm going to stop, and that pattern would continue. However, I'm stopping there because that's all I need for this particular example. In this example, I'm raising it to the 5th power, so I only need this particular row. And when you interpret this, when you look at this guy, this first row, when I'm raising it to the 0 power, I use this first row. Here's the 1st power, the 2nd power, the 3rd power, the 4th power, and the 5th power. And again, that's why I stopped there, because I'm raising this thing to the 5th power, so that's the one I was looking for. All right? In order to do binomial expansions with Pascal's triangle, the first thing I do is I write down my coefficients from that row. So I've got 1, 5, 10, 10, 5, and another 1. And then from here, I'm going to plug in my A's and my B's, because this is just me setting up my pattern before I actually plug in these values. When I do this, since it's to the 5th power, I'm going to start with an A to the 5th, and I just count down. A to the 4th, to the 3rd, to the 2nd, to the 1st, and then A to the 0, which means there is no A value, so I don't write it down at all. The B values, I do the same thing, but in reverse, so I start over on this end and do B to the 5th, then B to the 4th. I'm counting down to the 3rd, to the 2nd, to the 1st, and then to the 0, which means I don't write down the B value at all. I slap some plus signs in between, and keep in mind those plus signs might change depending on which values I plug in for A and B. And so when I do this, A and B are the two values from the binomial, but this time I don't have A and B. I've got, instead of an A, I have a 2x. Instead of a B, I have a -3. So right here, any place I see an A, I'm going to plug in a 2x. Any place I see a B, I'm going to plug in a -3. So right here I have an A, and I'm just going to plug in the 2x in its place. Same thing with this A. Every B value, I'm going to plug in the -3. And now from here, really, it's just a job for my calculator. I'm going to go ahead and plug each of these things in, like the 2x to the, I wrote a 2 here instead of a 5. Let me try again. So here I have a 2x to the 5th. Well, 2 to the 5th power is a 32. That's an ugly looking 3. Let me try again. And then I have the x to the 5th. Here I have a couple different things happening. I have to the 2x to the 4th power, which gives me a 16x to the 4th. Then I have to multiply that 16 by the 5 and the 3. And that gives me a -240 when I multiply all that out with an x to the 4th written down. The next one, I have the 2x to the 3rd power, which gives me an 8x to the 3rd. The -3 to the 2nd power gives me a 9, a positive 9, and then I multiply by the 10. So it looks like I get a 720 here and an x to the 3rd. The next one, the -3 to the 3rd power gives me a -27. The 2x to the 2nd power gives me a 4x squared. And then when I multiply the numbers that are left over here, I get a -1080, and I'll be left with an x to the 2nd. For the next one, I'm doing -3 to the 4th power, which is going to give me a positive 81. And then when I multiply that by the 5 and the 2 that are remaining here, I get a positive 810 with just a plain old x value. And then the last one, I do this -3 to the 5th power, which is going to give me a -243. And that's it. What essentially I've done here, instead of having to write out the 2x minus 3 5 times and FOIL like crazy and take up a bunch of room and combining very ridiculous-like terms, I can use this shortcut using the pattern given here from Pascal's triangle, plugging in my A's and B's, and just come up with the multiplication without all that work. Okay, so again, when you use Pascal's triangle, you pick the appropriate row, you write down your coefficients, write down your A's and your B's in descending and ascending order, and then plug in your A and your B values and simplify. And that's it.